Okay, so let's start with the problems on vectors now. So write down the first problem. Write down the first problem. Two forces, two forces of 5 Newton, two forces of 5 Newton and 7 Newton, two forces of 5 Newton and 7 Newton act on a particle, act on a particle with an angle of 60 degrees between them, with an angle of 60 degrees between them. Find the resultant force on the particle. Find the resultant force on the particle. I'll repeat the question. Two forces of 5 Newton and 7 Newton, two forces of 5 Newton and 7 Newton act on a particle, act on a particle with an angle of 60 degrees, with an angle of 60 degrees between them, between them. Find the resultant force on the particle. Find the resultant force on the particle. Did you all get the question? Let's start with the solution. So there are two forces given to us, F1 and F2, let's say. So F1 is given to us as 5 Newton and F2 is given to us as 7 Newton. So magnitude of F1 and F2 are given. And the angle between them is given as 60 degrees. We have to find out the magnitude of the resultant force. So resultant force will be given by the formula root of F1 square plus F2 square plus 2 F1 F2 into cos of angle between them, that is cos of theta, which will be equal to root of 5 square plus 7 square plus 2 into 5 into 7 cos of 60. Just substitute. So we'll get this as root of 25 plus 49 plus 70 multiplied by cos of 60 is half. That is going to be root of 74 plus 35, which is going to be root of 109. So using log tables you can find out root of 109, which will come out as 10.44 newtons. This is going to be your final answer. So if you directly use the formula when the magnitudes are given to you to find out the resultant. Okay, write the second question. A motorboat is racing. A motorboat is racing. A motorboat is racing towards north at 25 kilometers per hour. Towards north at 25 kilometers per hour. And the water current in that region is 10 kilometers per hour. And water current in that region is 10 kilometers per hour. In the direction of east of south, in the direction of east of south, full stop. Find the resultant velocity of the boat. Find the resultant velocity of the boat. I'll repeat the question. A motor boat is racing towards north at 25 kilometers per hour and the water current in that region is 10 kilometers per hour. Okay, so this is velocity of the current and this is velocity of the boat. In the direction of 60 degrees east of south, find the resultant velocity of the boat. Okay, let's proceed with the solution. So let's draw the directions first. This is east, west, south and north. So the motor boat is racing towards the north. So motor boat is going in this direction, in the north direction, with a speed of 25 kilometers per hour. So V boat is equal to 25 kilometers per hour. And then there is water current in that region moving with 10 kilometers per hour in the direction 60 degrees east of south. Now 60 degrees east of south meaning which side it will come? 60 degrees east of south will be in this direction. So you have to look at south and see your right hand side. You have to stand facing the south and on the right hand side will be your east. East of south. Okay. So basically if you see, if you find out east of north, it is on the right. Correct? Normally east is on the right of north. So that this particular reference you have to take. That is east is on the right always. Okay. So face towards the south and on your right will be your east. Okay. So east of south will be this side. If they said west of south, it would have come on this side. Okay. So this is your direction of water current. So VC is 10 kilometers per hour, which is making an angle 60 degrees from the south. This is what is given to us. Okay, so the smallest angle between the two vectors VB and VC will be this particular angle which I mark in red, that is theta. So theta is going to be, this is 90 plus this part, remaining part over here is going to be 30. So 90 plus 30, that is going to be 120 degrees will be your theta in this case. So you have to find out the resultant velocity. So resultant velocity, magnitude of resultant velocity will be equal to root of VB square plus VC square plus 2 VB VC cos of theta. This is going to be equal to root of 25 square plus 10 square plus 2 into 25 into 10 into cos of 120. This is going to be equal to root of 625 plus 100 plus is going to be 500 multiplied by minus half. Cos of 120 is minus half. It's going to be, answer will be root of 475, final answer. Okay, so that is going to be, using log tables you can find out, it is going to be 21.79 kilometers per hour. This is going to be the resultant velocity magnitude. Write down the third problem. A body is simultaneously given. A body is simultaneously given. A body is simultaneously given two velocities a body is simultaneously given two velocities of 30 meters per second due east and 40 meters per second due north and 40 meters per second due north. Find the resultant velocity. Okay, so resultant velocity vector magnitude is going to be root of VE square plus Vn square plus 2VE Vn cos of theta, where theta will be here 90 degrees because one velocity is going towards north and one is going towards east. So angle between them is going to be 90 degrees. So root of 30 square plus 40 square plus 2 into 30 into 40 cos of 90 degrees. Or we have seen the special case while doing the derivation. You can use the same special case formula also over here. Okay, that is root of a square plus b square plus 2ab. Okay, because cos of 90 will be 1. Sorry, cos of 90 will be 0. So you can use root of a square plus b square. Correct? So root of 30 square will be 900 plus 40 square will be 1600. This term is going to go to 0. It is going to be root of 2500, which is 50 meters per second. Okay, write the next question. If vector A on top you have to write a arrow, okay? That is vector A is 3i plus 2j and vector B is equal to I minus 2j plus 3k. Find the magnitude of A plus B and A minus B. Find the magnitude of A plus B and A minus B. Okay, so let's start with the solution. So here we are going to use the analytical method which we have studied to find out A plus B and A minus B, because A and B is given to us in the component forms. So how will we find out A plus B? A plus B will be what? You have to directly add the X component, directly add the Y component and Z components together. Okay, so before that, just to understand, I'll write one step. So let's substitute 3i plus 2j plus I minus 2j plus 3k. Okay, just add them together. So what will happen? I and I terms will get together, added. 3 plus 1 is 4i, j and j term together, so plus 2 minus 2 will be 0, so plus 0j. And last term over here, k term is missing over here, but k term is there over here, so plus 3k. It's as good as 0 plus 3 will be 3k cap. Okay, so this is going to be your A plus B vector. The resultant of A plus B will be this. This is what we have studied in the analytical method. Now we need to find out the magnitude of a plus b. So what will be magnitude of a plus b? How do we find out the magnitude over here? In the component form, it is root of ax square plus ay square plus az square. That is our formula, right? So it's going to be 4 square plus 0 square. No need to write this, but just for understanding, plus 3 square. If you are given a vector a in the form axi plus ayj plus azk, then how do we find out the magnitude of a? That is going to be root of ax square plus ay square plus az square. Just square the terms and take a root of the sum. Okay. So here also same thing. This can be treated as resultant, one vector. Okay. So this can be considered as rx, ry and rz. So rx square plus ry square plus rz square. This is how it will work. Okay. So now let's find out. This is going to be root of 16 plus 9. It is root of 25. Okay. So what is going to be the magnitude here? Magnitude is going to be 5 units. Now we will find out a minus b. Vector a minus vector b. So what we are going to do here? 3i plus 2j minus I cap minus 2j cap plus 3k cap. So here it's going to be 3 minus 1 will be 2i. 2 minus of minus will be plus. So 2 plus 2 will be plus 4j. Here it's 0. So 0 minus 3 will be minus 3k cap. This is going to be a minus b vector. Vector a minus vector b. So if you want to find out a minus b magnitude, it's going to be root of, again, ax square plus ay square plus az square. This is going to be root of 4 plus 16 plus 9. That is going to be root of 29, which will come out as 5.38 units. This is going to be the magnitude of a minus b. Okay, note down the next question. Find a unit vector. Find a unit vector parallel to the resultant. Find a unit vector parallel to the resultant of vectors a, which is equal to I cap plus 4j cap minus 2k cap, and b, which is equal to 3i cap minus 5j cap plus k cap. Find a unit vector parallel to the resultant of the two vectors a and b, which is written on the board. So let's go to the solution. So here we need to find out a unit vector which is parallel to the sum of these two vectors, or addition of the two vectors. So first we'll have to find out the addition of the two vectors a plus b. So a plus b is going to be I cap plus 4j cap minus 2k cap plus 3i cap minus 5j cap plus k cap. This is going to be what? 1 plus 3, 4i, plus 4 minus 5 will be minus j, minus 2 plus 1 will be minus k cap. This is going to be your a plus b vector. So magnitude of this vector will be what? Because see, what we have to do over here is a plus b vector, okay, will be equal to the magnitude of a plus b into direction of a plus b. Cap. Correct? This is what it is going to be. A plus b magnitude multiplied by direction is going to be its vector addition. Okay, like for example, if we, or rather we'll write it this way, if we treat a plus b as vector c, if this is equal to vector c, so what will be vector c? Vector c is going to be equal to magnitude of vector c into direction of c. Okay, so what will be direction of c? It is going to be vector c upon magnitude of vector c. So for that we require the magnitude of vector c. So we'll find out the magnitude of vector c. So magnitude of a plus b, which is magnitude of c, will be what? Will be equal to root of 4 square plus minus 1 square plus minus 1 square. That is going to be root of 16 plus 1 plus 1, that is root of 18 units. This is going to be the magnitude. So what will be c cap over here, or a plus b cap over here? That is going to be a plus b vector divided by magnitude of a plus b. This is using this logic, okay, as vector c logic. So this is going to be, write down the vector on top, 4I cap minus j cap minus k cap, the whole divided by root 18. So I'll write it over here, 1 upon root of 18 is equal to, okay, in this bracket. So this is going to be your unit vector, which is parallel to the resultant of A and B. Write the next question. A old man walks 10 meter. A old man walks 10 meter due east. A old man walks 10 meters due east from his house, and then turns to his left, at an angle of 60 degrees, with the east. 60 degrees with the east. Full stop. He then walks 10 meters in that direction. And sits on a bench. His grandson, after seeing him, runs straight to him from the point old man started his journey. Full stop. How much distance his grandson travels to reach him, and in what direction he ran. I'll repeat the question. An old man walks 10 meters due east from his house and then turn to his left at an angle of 60 degrees with the east. He then walks 10 meters in that direction and sits on a bench. His grandson, after seeing him, runs straight to him from the point old man started his journey. How much distance his grandson travels to reach him and in what direction he ran? Okay, so let's draw the figure first for this problem. So a grandfather or an old man, he walks 10 meters towards the east. So let's consider this as east, west, north, west and south. Okay, so he walks 10 meters towards the east, and then after he walks 10 meters, he then walks 10 meters in the direction which is at an angle of 60 degrees with the east. Okay, so basically he changes his direction like this, which is 60 degrees to the east, something like this. So basically this remains as east, and this angle is here is going to be 60 degrees. Okay, then he walks over here and travels another distance of 10 meters. So his grandson comes over here at a point where the old man started. He sees him sitting at this point on the bench, and he straight away runs directly through the garden. Okay, so he will straight away run like this in this direction to this particular point. So we need to find out this resultant of the two vectors. Okay, so now if you see, if I consider these two vectors, this is going to be my one vector 10 meters towards east. If I join this point over here, this is going to be the case. Okay, and this angle between the two vectors is going to be 60 degrees. So this vector, distance vector, is going to be 10. The first distance vector is going to be 10. The second distance vector is going to be again 10 meters. Magnitude will be 10 meters. Okay, and the angle between the two vectors is given as 60 degrees. Okay, so you have to find out the resultant over here. So what will be the formula? The same formula R we will use. It will be root of, I will directly substitute now. So 10 square plus 10 square plus 2, 10 multiplied by 10 into cos of 60 degrees, angle between them. So after you solve this, you will get it as root of 300, which is going to be 17.32 meters. This is going to be the distance that grandson runs with. Okay, this much distance. In the second question, they have asked how much distance his grandson travels to reach him and in what direction. So basically, what is the direction of that running? Let's say this angle is alpha. How much angle that grandson takes from the east direction? So we know tan of alpha formula. Tan of alpha is equal to B cos sine of theta, or sine of theta divided by A plus B cos of theta. Okay, substitute 10 into sine of 60 divided by 10 plus 10 into cos of 60. So once you solve this, you will get this as, this value would come as 1 upon root 3. Okay, so alpha is going to be tan inverse of 1 upon root 3. So what is the angle which gives us the root 3 value? Angle which gives us the root 3 value is 30 degrees. So grandson ran at an angle of 30 degrees due north of east, you can say. Okay, so grandson, so how to specify the direction? We'll have to say that grandson ran at an angle of 30 degrees due north of east. Write down the next question. A particle moves from a point A 2, 3 A 2,3 to B 6,4, to point B 6,4 in xy plane, in xy plane, in the time interval of 2 seconds, in the time interval of 2 seconds. Find the displacement vector, find the displacement vector of the particle, find the displacement vector of the particle in the given interval. Find the displacement vector of the particle in the given interval. Repeat the question. A particle moves from a point A 2,3 to point B 6,4 in xy plane in the time interval of 2 seconds. Find the displacement vector of the particle in the given interval. So let's draw the Cartesian plane, xy plane. X-axis, y-axis. Let's mark the 2 points. A 2,3, let's say 2 is over here, 3 is over here. So this is point A 2,3 and point B is 6,4. So 4 let's say is here and 6 is over here. So B is 6,4. So let's mark their position vectors now. So let's say R1 is the position vector of A and R2 is the position vector of B. So our particle is moving from A to B like this. So we have to find out this displacement vector over here. Okay. So let me write down the two vectors. R1, let's say vector R1 is, I'll just denote it x1i plus y1j just for understanding. So it is going to be 2i plus 3j. If you consider this as x1, y1, this is x2, y2, and R2 vector, the position vector of point B, is x2i plus y2j, so it is going to be equal to 6i plus 4j. These are going to be your two vectors, so R1 and R2. So what will be the position vector? Delta R, let's say, is going to be equal to the final position minus initial position, normal formula. We are going to learn this in detail in the theory part, but since we have this question here in line, just we'll go through it. Okay, so the position, final position minus initial position is going to give you the displacement between the 2 points. Okay, so what you are going to do over here is R2 you substitute 6i plus 4j minus R1 is 2i plus 3j and take the difference between them. So 6 minus 2 will be 4i, 4 minus 3 will be minus 1, plus 1, that is j. Okay, so what is going to be the magnitude of this displacement vector? The magnitude is going to be root of rx square plus ry square, so 4 square plus 1 square, that is going to be 16 plus 1, that is going to be root of 17 units. You can keep it as root value, no problem. This is going to be your position vector delta r, displacement vector delta r. Note down the next question. What is the angle between 2 Newton force and 3 Newton force? What is the angle between 2 Newton force and 3 Newton force so that their resultant is 4 Newton? So that their resultant is 4 Newton? Question mark. I'll repeat the question. What is the angle between 2 Newton force and 3 Newton force so that their resultant is 4 Newton? Question mark. So they have said that angle we have to find out between 2 Newton force and 3 Newton force. Resultant is given to us as 4 Newton. So F is given to us root of F1 square plus F2 square plus 2 F1 F2 cos of theta. So now F is given to us, resultant force is given to us as 4, root of F1 is given to us as 2, so 2 square, F2 is 3 square plus 2 into 3 cos of theta. So what I will do is squaring on both sides. So this is going to be 4 square, that is 16, is equal to 2 square, that is 4, root sign will go, 3 square will be 9 plus 2 2s are 4, 4 3s are 12 cos of theta. So this is going to be 16 minus 9 plus 4 will be 13 is equal to 12 cos of theta. So this is going to be 3 upon 12 is equal to cos of theta. Okay, so theta is going to be cos inverse of 3 upon 12. It is going to be cos inverse of, this ratio is going to come to 0.250. Okay, cos inverse of this is, it's okay, you need not find it out. This much is fine. Even this much is fine. Cos inverse of 3 upon 12 is enough. Write down the next question. Write down the next question. The magnitude of x and y component, the magnitude of x and y component of vector A, the magnitude of x and y component of vector A are 7 and 6 respectively. Full stop. I'll repeat. The magnitude of x and y components of A are 7 and 6 respectively. Full stop. Also, the magnitudes of x and y component, the magnitude of x and y components of A plus B, vector A plus vector B. Also, the magnitudes of x and y components of vector A plus vector B are 11 and 9 respectively. Calculate the magnitude of vector B. Calculate the magnitude of vector B. We need to calculate the magnitude of vector B. I'll repeat the question. The magnitude of x and y component of A are 7 and 6 respectively. Also, the magnitudes of x and y components of A plus B are 11 and 9 respectively. Calculate the magnitude of vector B. Now, how do we write vector A? Vector A in its component form is written as ax I cap plus ay j cap, and the components are given to us in x and y. Components are given to us 7 and 6. So A I can write as 7i plus 6j. 7i plus 6j. Similarly, A plus B, components are given to me in x and y direction, so I can write it as 11i plus 9j. So I need to find out magnitude of B. For that reason, I need to find out the vector B first. Correct, no? So what will be the formula? We know that vector A plus vector B is nothing but vector A. I'll substitute over here. Okay, so this is going to be 7i plus 6j is vector A plus vector B I do not know. Okay, and in place of A plus B I'll put whatever A plus B is given to me. It is 11i plus 9j. This is A plus B. Okay, so what I can do over here? What I can do over here is, or rather if you are getting confused, I can write it this way also. This is going to be bxi cap plus by j cap. Okay, so we'll include one more step over here just to avoid complication. So a plus b is going to be equal to axi plus ayj plus bxi plus byj. Now it will be clear to you. Okay, now we can substitute. So a plus b is given to us as 11i plus 9j is equal to axi plus ayj I know as 7i plus 6j plus this will remain as it is bxi cap plus byj cap. In the next step I will take this on the other side. So what I will get is 11i plus 9j minus 7i plus 6j is equal to, since it is going on the other side, it will become negative, is equal to bxi plus byj. So 11 minus 7 is going to be 4i, 9 minus 6 will become plus 3j, is going to be equal to bxi plus byj. So you got a vector b from here now. Okay, so we need to find out the magnitude of b. So magnitude of b will be what? Root of bx square plus by square. This is going to be equal to root of 4 square plus 3 square, that is going to be root of 16 plus 9, that is 25, which will be equal to 5 units. So that is going to be the magnitude of vector b. Yes, so these are the problems based on vectors. In the next class we are going to learn the multiplication of vectors, that is vector product and scalar product. Okay, so we'll stop here for today.